control of solar gains is a very important strategy for the design of energy-efficient buildings, especially in hot climates. For this reason, the designer must be provided with appropriate tools to study the effects of shadows on windows, facades and other building parts. The graphical tools that we will see in this lesson are among the most effective and easy to use. The first one are sum path diagrams, which can be used for studying the shading related to a particular site, or better, point of analysis, during the year by drawing the profile of the sun obstruction due to the surroundings, mountains, buildings, trees, and using the same angular coordinates that are used to describe the position of the sun. For example, a treetop, after having ideally drawn its line joining the observer, can be identified by two angles, alpha prime and beta prime, and so its whole profile. Dark areas identify the periods in which the point of analysis, with respect to which the diagram was drawn, is shaded. The solar shading protractor is another useful tool, which allows to study the effects of sunshades, overhangs and fins on the building facades. The shading protractor has the same dimensions of the polar diagram and can be overlaid to it. It is used to show the shading effects caused by vertical and horizontal overhangs with respect to a specific point of view, which must coincide with the center of the chart. Colored areas identify the periods in which the point of analysis with respect to which the protractor was drawn is shaded. The basis of the protractor is represented by a set of concentric curves and circles intersected by radial lines. The horizontal curved lines represent the influence of shadows created by overhangs characterized by horizontal edges parallel to the facade and are drawn by calculating the angle epsilon. This is the angle lying in a vertical plane orthogonal to the facade, formed by the horizontal line passing through the analysis point P and the line joining this point with the outer edge of the horizontal overhang. The corresponding values can be read on the vertical lower semiaxis of the diagram. The vertical curved lines, which are the extensions of the concentric semicircles contained in the upper half of the diagram and converge at point B, take into account the influence of shadows created by horizontal overhangs with edge perpendicular to the facade. These lines are identified through the calculation of the angle sigma lying in the plane of the facade and formed by the horizontal line passing through the point P and the line joining P with the terminal point of a horizontal overhang or with the upper limit of a vertical overhang. The values of sigma are readable on the upper vertical semiaxis in correspondence of its intersection with the semicircles. In the same way, also the influence of the upper limits of vertical overhangs can be visualized. For example, here you can see the protractor drawn up in relation to a horizontal shading. Furthermore, the radial lines that branch out from the center in the bottom half of the diagram represent the influence of shadows generated by vertical overhangs. This line indicates the value of the angle omega, laying in the horizontal plane orthogonal to the facade and formed by the horizontal line perpendicular to the facade, passing through the point P and the line joining this point with the outer edge of the horizontal overhang. The values of omega are readable on the external circumference of the diagram and are symmetric with respect to B. For example again, here you can see the protractor drawn up in relation to a vertical sunshade. In the previous examples, situations corresponding to facades exactly south-oriented were shown. It is, of course, always possible to consider any other orientation by rotating the protractor and aligning the lower vertical semiaxis with the normal to the facade. So, in this picture you can see how a horizontal obstruction on a southwest facade is plotted. It is also possible to combine the coincident effects of vertical and horizontal obstruction by reading on the same diagram the relative values of epsilon, sigma and omega. Finally, It should be noted that it is the angular geometry and not the actual physical size which determines the mask obstruction. For example, a single large horizontal overhang or a series of horizontal blades with the same overall angle of obstruction generate the same mask. The graphical tools which have been shown can be used to verify shadow effect in a site or on a building, but also to properly size the shading elements. Through some simple graphic steps, in fact, the designer can study with sufficient accuracy the effects of various types of obstruction as solar screens.